Hello everyone, welcome to this new video. So in this today's video, we'll be solving the problem, check whether BST contains dead end. So this is an easy level problem and it's the problem of the day on Geeks for Geeks today. And the company tags of this question is coordination and the topic tags is binary search tree. Alright, so let us go to the question now. So given a binary search tree that contains unique positive integer values greater than 0. Okay, so this is a point to be noted. So all the values in the binary search tree are greater than 0. The task is to complete the function is dead end. So which returns true if the BST contains a dead end, else returns false. Here dead end means a leaf node at which no other node can be inserted. So we'll see that in brief, we'll understand in brief by the examples given. So this is example 1 and this is example 2. So your expected time complexity is O of n, where n is the number of nodes in the BST, and expected space complexity is O of n as well. So but we'll be solving this problem in the most efficient manner, the most optimal solution, like time complexity is O of n and space complexity is O of h. H is the height of the binary tree. Great. So for other solutions, you can refer to other videos or editorials, but in this video, I'll be only explaining the most optimal solution. And the n values goes up to 1001 and values of nodes goes up to 10,001. Okay, starting from 1 each. And before we proceed further, I would like to just mention that I was not able to upload the videos for the last 2 days because I was occupied with my end semester examinations. So I hope you people understand my situation, but I'm trying my best to make sure I upload the videos consistently and regularly. All right, so now let us go to the this explanation of the test cases. So this is the first test case. So why is a 1? So this is the BST that has been given. Okay, this is the BST that has been given to us, and now the output is yes. What is the explanation that has to be said? So node 1 is a dead end in the given BST. Why is node 1 a dead end in the given BST, this particular node 1? Because what are the values that you can insert at this particular one? All right, to the left and to the right. So I hope you people know the properties of the BST. So BST in the sense left values must be less than root value. Okay, and that must be less than right side value, right? That must be less than right side value. So this is the formula, isn't it? This is the formula. So if I'm on 1, if I'm actually standing on 1, what are the values that I can insert to the left of 1? All the values that are less than 1. But are there any possible values that are less than 1? Only 0. But can 0 be inserted? No. According to the question, all the values of the BST must be greater than greater than 1. So I cannot insert 0 to my left. Okay, let us try if I can insert something to my right. Can I insert anything to my right? So what is the just number that's just greater than 1? 2. But 2 is already there in the BST. So whatever the value that is greater than or equal to 2, like equal to 2 is already there. So greater than 2, whatever the value will be inserting to the right side of 2, but not to the 1, isn't it? So that is the reason it's a dead end, right? It is a dead end. It is a dead end. So you cannot insert any value to the left of 1 and to the right of 1. So that is the clear-cut explanation of dead end. Similarly, if you can check here in the example 2, the output is yes as well. Okay. And what does the explanation have to say? So we see 9. Node 9 is a dead end. So when you stand on node 9, okay, when you stand on node 9, what are the values that you can insert to the left of 9? All the values starting from 1 to 8. Okay, 1 to 8, both inclusive. And to the right of 9, all the values that are greater than 9, that is 10, and that can go up to the maximum possible value, like 10,001 or something. So it can go. But can you insert any values from 1 to 8 to the left of 9? No, because already 8 is there in the BST. So whatever the values that are there in 1 to 8 region will be inserted in the left side of here, right? In the left here. So it will not go to the right side of 8 because 8 is already present in the map. Sorry, in the BST. And what about the values greater than 9? So left hand is done. Left hand we cannot insert anything to the left. And what about right? Right side, any values that is greater than 9. So starting from 10 to the maximum. But do you find 10 in the BST? Yes, I already have 10 in the BST. So what are the values that are greater than 10 will be inserted to the right side of 10. Right, to the right side of 10, but not to the right side of 9. So even right side it's a block. So in both left it's block and right it's block. So completely it's a dead end, right? So that's the reason it is a dead end. I hope you people are understanding about what's the definition of dead end. So dead end basically means that you cannot put any values. Okay, you cannot insert any values to the left or to the right. That's how it simplifies to. All right. So I hope you people understood. There's a dead end from the left as well as right. So there is no value that you can insert to the left of 9 and to the right of 9. So it's a dead end. So that is the reason we return true. So I hope you people understood. Now let me erase all these things. Okay, just to get some better clarity. We'll be framing the approach, the most optimal approach for this particular question, and I hope you people will understand it. So just give me a moment erasing all this stuff. Okay, so if I just need to put the definition of dead end in words, okay, dead end. So what should I put for the dead end? So dead end basically means that there is a place for insertion. There is a place for insertion. There is a place for insertion, but you cannot put anything. But we cannot insert anything. Okay, we cannot insert anything. This is very important. Okay, this is very important. We cannot insert anything. You might even consider like this to be a dead end, because in your definition, in your own definition, you might consider 5 to be dead end, because you cannot insert anything to your left, you cannot insert anything to your right, because it's a binary search tree. Right side is already there, left side is already there, so you cannot insert anything else. So you might think this is also a dead end, but no, that's not a dead end. The dead end says that dead end is such a place that is actually dealing with the leaf nodes, where you have nothing to insert, where you have nothing, like where you have place to insert to the left and to the right. Okay, you have the place to insert. Okay, but you cannot insert because of the things like the constraints that we have in the BST, that all the values to the left of a particular node must be less than the root value, and to the right of the root must have greater than the root value. So because of that constraint, we cannot put anything there, but there's a place to put. Okay, so if that is the case, then we term it as a dead end. Okay, then we term it as a dead end. So if I would like to simplify this particular question, let us assume there is an apartment like this. Okay, so there are various residents. Okay, there are various residents like this, and what is the condition of this particular thing is all the values must be unique. All the values must be unique. What do you mean by values? What do you mean by the value, like values, meaning of values? This is the net worth of each resident. Okay, net worth of each resident. Let us assume I have a person at the top floor with 105 crores as net worth. All the persons below this particular person when living at the below the top floor must have the values less than 105. Let us assume I'm saying this. So if you're on this particular thing, like, and your value of assets might be 1 or 2, so all the people living above to you, or like in the top of you, must have greater than 1 or 2. Okay, greater than 1 or 2, and to the bottom must have less than 1 or 2. So this is the condition that I've put. And what will you check? Now you have your friend that you want to like ask him to be in your apartment, like you want to give some house to your friend in your apartment. So what is the condition that you'll check? You'll just check that do you have any vacancies, or do you have any vacancies for those values like that are greater than 1 or 2, right? What can that be? 103 and 104, but not greater than 105, because 105 is the topmost thing, isn't it? 105 is the maximum that it can go up to. So 105 is already occupied. So what are the feasible values that you can look out for? 103 and 104. If 103 is vacant, like if 103 crores asset person is not there in your apartment till now, then you can give that to him, your friend, because your friend might, if your friend might have 103 crores asset, then he can happily come here, or 104 crores asset, he can happily come here, because all these two are vacant as of now. Similarly, less than 102 in the sense it can be 100, 101, like till the minimum value. Okay, till the minimum value, right? So it's basically you're trying to look out, you're trying to find some vacancies where you can insert your friends, provided that your friend value matches with it. But let us assume like here you have 104, you have your 103, here you have 101, here you have 100, here you have 99. So once you are at 102, okay, you're standing at this point, this is your floor. Okay, how do you do the search? You will be going to the top and you'll be checking if you have any values from 103 to 105, isn't it? You will be checking, do you have any values in 103 to 105, like, or 103, 104, anything is fine. So 103 to 104 in the sense you're checking if you have any values with 103 and 104. And to the bottom, what will you be checking? Let us assume the minimum most value is 99. So you'll be checking for the values from 100 to 101, isn't it? Like 100 or 101 if any of them are vacant, or in the top, like this is top search, this is bottom search. Okay, so in the top search you'll be checking for 103 or 104 crores as set of value if it is vacant, or in the bottom you'll be checking 100 and 101. Okay, so that's how you'll be checking, right? So same thing you'll even apply to this particular problem also. So to the left and to the right, if you're standing on a particular node, what are the values that you're going to search? You'll be searching for, if like this is a root value, so you'll be checking for the minimum most. In this case, minimum most, what's the minimum most value? 1, and root value -1. Okay, you'll be checking for all these values. And to the right you'll be checking root value +1, and to the maximum value. What's the maximum value? Maximum value of node that it can go 1000, 10,001. Okay, so you'll be checking for all these things. We can come to a conclusion that we found the dead end when the search minimum value is actually equal to the maximum value, provided that the root is already present. Okay, so provided these two values, these two conditions, then we can say that we have found the dead end. Okay, now let us dry run this particular conclusion on this example, and so that we can get a better clarity. So let us assume you're standing on this particular 8. Okay, consider this example 2. You're standing on particular 8. So what are the values that you'll be looking out to your left of 8? You'll be looking out for the values 1 to 7. Okay, both inclusive. All right, 1 to 7. And now when you come to 7, what are the values that you'll be looking out to the left of 7? 1 to 6. Okay, so 8 first instructs 7 to look out for the values from 1 to 7. 7 instructs 2 to look out for values from 1 to 6. Now 2, what does it instruct to the root to the left of it? Like now you have on this particular position, what are the things that you will be instructing to the left side of yours? To search the values from 1 to 1. But do you find any node to the left of 2? No. So you can happily insert 1 here. Okay, if you wanted to insert 1, you can happily insert, like, because 1 is not there, root is not there, you can happily insert 1, 1, right? So that it's done. Okay, now at 7 you're done with the left, at the 2 you're done with the left, and you still have a right. What are the values that you'll be checking for the right? The maximum value. To figure out that, ask 7 what is the maximum value that I can go up to. So for 7 would be asking 8 what is the maximum value that I can go up to. So 8 says that search in the range of 1 to 7, right? Search in the range of 1 to 7. So minimum is this, maximum is this. For 7, okay, for 7 the minimum is 1 and this is the maximum value that it can search to. So for 7 would be searching in the right, the values that are greater than it, so that would be 8, and the maximum value that has been provided to it to search 7. So it's not defined practically, it's not particularly defined, and also there is no node to the right of 7. So you can happily like consider it as it's not a dead end, because there is no root here, there is no node here, right? There is no node here, there's an absence of a node. So I've clearly instructed that if you wanted to find a dead end, that must make sure that you are actually having a node. Okay, you must actually have a node, then only it can be considered as a dead end, then only this particular thing can be considered as a dead end, right? But there is no node to be considered as a dead end, so it's fine. So this is gone, this is gone. So 7 instructs the same thing to particular 2. So the values that it can go up to is 7 instructs 2 to check the values from 1 to 6. So for 2 the maximum value that it can go up to is 6. So and the minimum value that it can search on the right is 3. So 3 to 6 is what it will be searching, right? Because to the right side of 2 all the values should be greater than 2, so that can start from 3, and what is the maximum value that it can reach to? It's only 6, because 7 has instructed to only search for values from 1 to 6. So 3 to 6, and you see that there is no node here, there is no node here, so you can happily insert any value between 3 to 6 in this particular case, right? So there is no dead end to the left side of 8. So this is done. Okay, let us now erase this particular thing, and go to the right side of it. Okay, go to the right side of it. So here we have searched from 1 to 7. Now into the right side of 8, what will you be checking for? Starting from 9, that goes up to 10,001. Okay, now you'll be coming on 10. This is what you'll be instructing to 10 to search for. This is the range that you'll be giving for 10. And now 10 has received this. This is the minimum value it has received. This is the maximum value that it has received. Okay, so for 10, what is the thing that you're going to do? So for 10's minimum search would be to the left. Okay, to the left, what it's going to get? To the minimum, it's going to start from to the left of 10. To the left of 10, it's going to start from the minimum value, that is 9. So this is the minimum value that it has got from 8. Okay, this is the minimum value that it's got from 8. You'll be inserting 9 here. And what's the maximum value that it can go up to? To the left of 9, all the values should be less than 10. That is 9. So 9. And when you come here, yes, you found a node. You are on a node, and you see that for this 9, the minimum value that it need to search and the maximum value it need to search, both are same. Okay, you have come to a node. Okay, you have got a node. Leave about its value. You have got a node, and for that node, the minimum value that it need to search and the maximum value it need to search, both are same. So it's a dead end, because you cannot insert any value to the left of 9. Like, what are the values that are left to 9? Less than or equal to 8. So all those values will be inserted in this particular left of it. And what are the values that can be inserted to the right side of 9? Anything that is greater than or equal to 10. Anything that is greater than or equal to 10 will be inserted in this particular right side. So what values can you insert here? Nothing. 0. It's a dead end. Okay, it's a dead end. So I hope you people are understanding what is the true definition of a dead end. So you have reached to that point, you have reached to that node where the minimum value that you can insert or the maximum value, like minimum value you can search or the maximum value you can search, both of them have been the same. Both of them are same. So there's no value that you can actually try to insert. So that's a dead end. I hope you people understood. So because 10 has got the instruction to search only the values from 9 to 10,001. So the same instruction has been passed to 9. So only search from the minimum value, that is 9. Okay, this is the minimum value that I'm providing to you. Search from that to what are the maximum values that you can. So for 9, to the left of 9, what it can search, minimum value that it has got from 10, that is 9. And to the left of 9, what are all the values that it can insert? The values that can go up to, like that has got from this particular 10. So the maximum value that it can give, so 9. So both of them are same. So you cannot actually you did not find anything that you can insert. So it's a dead end. So I hope you people understood what are we trying to do. We are trying to sort out figure out such a node where it's left, like its minimum value that it need to search and the maximum value it need to search, both of them are same. Okay, both of them are same. It has got a clear instruction from 10 to do this following search, starting from 9 until goes up to 10,001. So that is what 10 has passed on to 9. So 10 passed to the 9 that maximum value that you can search is 9, and minimum value that you can search is 9, because all the values to the left of 10 must be less than or equal to 9, right? So this is what it will be passing to 9, and both of them are equal. So that's it, done. So there's nothing to insert for 9. So I hope you people understood. I put a very clear cut explanation, grassroots level explanation for this particular question. If there are any doubts, please feel free to comment in the comment section. Okay, so now let us go to the code. So we'll write the code now. So it's basically return. We'll be defining another function for this. Return has dead end, and that has root, and the starting value is 1, minimum value, and the maximum value is 10,000. Okay, and bool has dead end. Okay, and that is node start root int min val and int max val. Okay, int max val. So if in case your root is not defined, okay, if in case your root root is none, So root is null. Where is it? Yeah, then you return false. Okay, return false. You must be sure that you need to have a root, and if in case your root is there and your minimum value turns out to be your maximum value, then return true. Okay, return true. And now if that's not the case, do the bool onto your left. Return has dead end onto your left. And what's the minimum value when you're actually trying to your left? It would be the same minimum value, but the maximum value is root data minus 1 to your left, right? Or okay, or has dead end root right side. And what's the minimum value in this case? Root data plus 1, because all the values to the right side must be greater than root data, and maximum value, it can go up to the maximum original value. Okay, so if in case you find something to your left or something to your right, you can actually return true. Like both of these are valid. One of them you can find in the left or right. Dead end in you just need to make sure there's at least one dead end. So if it can be in the left or right, it doesn't matter. So that's the reason we have put or. It's not mandatory that you need to find the dead ends in both the sides. So we can even submit for your reference. It's fine, it's working. So I hope you people understood. So for your reference, course in Java, Python, C++ are there in the description. Please go through them, and if there are any doubts, please feel free to comment in the comment section. I've explained the most optimal solution, and as said, the time complexity is O of n because we are visiting all the nodes, and the space complexity is O of height of the tree because we are using the recursion stack space that only goes up to the root height of the tree, isn't it? So that is the reason this particular thing is one of the most optimal solutions, right? So yeah, thank you for watching, guys. Stay tuned.